Good morning. So today we're going to look at the opposite of exponents and we're going to look at radicals. So a radical is where you have this radical sign which looks almost like a little division sign. Okay, so this is called your radical. You're going to have a number underneath the radical, which that is called a radicand. And then the number on the outside right here, this little small, this is called your index. That's basically the root of the radicand. So if there's no index right there, it is understood to be 2. Okay, so underneath the radical sign, you're going to want to find a perfect square. So let's talk about, or perfect cube, or perfect fourth, or whatever this index is. You want to find two numbers that give you that. So, oops. Let's think back onto our perfect squares. Okay, 1 squared is a 1, 2 squared is a 4, 3 squared is a 9, 4 squared is a 16, 5 squared is a 25, 6 squared is a 36, 7 squared is a 49, 8 squared is a 64, 9 squared is an 81, 10 squared is a 100, 11 squared is a 121, and 12 squared is a 144. Okay, so that's basically going up to 12 is what you're expected to kind of just know. So 1 squared, that was a 2 squared, your 9 was a 3 squared, your 16 was a 4 squared, your 25 is a 5 squared, 36 is a 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared. So taking a perfect square root then is basically finding the square. So finding the square. They're not always going to be perfect, so we're just going to start with this one first. So a perfect square root would be if I asked you to take the square root of 16. Okay, the perfect square root, that's understood 2 on the index there. Okay, so 16 is the same thing as saying 4 squared under there, right? The square root of a square basically goes away, so you're going to be left with the whole number 4. So anytime you have a perfect square underneath there, so the square root of 25 is going to be a 5. Square root of an 81 is going to be a 9. Square root of 25 over 36. 25 is a perfect square, 36 is a perfect square, so this is going to be 5 over 6. Square root of, we'll say this, so let's say 18 times the square root of 4. So it's 18 times the square root of 4. So the square root of 4 is a 2. So this is going to be 18 times 2, which is a 36. The square root of 1 over 16. Square root of 1 is a 1. Square root of 16 is a 4. So basically you want to find two numbers that multiply together. So let's look at this 81. 81 is 9 times 9, which is 9 squared. So there's two of the same number. So you're able to remove that radical sign and you're going to be left with just a one of those 9s. Okay? What if they're not perfect? Okay, so non-perfect square root. Okay, so you are going to find the largest perfect square that you can. That the radicand is divisible by. Break the radical down. Okay, so then you're going to take the square root of the perfect square. So basically, take it out of the radical. So whatever's left over stays underneath the radical. Okay? All right, let's do an example. So let's find the square root of 24. Okay, so square root of 24 is what? 2 times 12, 3 times 8, 4 times 6. So 4 out of this is the only perfect square. Okay, so 24 can be broken up into the square root of 4 times the square root of a 6. The square root of a 4 is a perfect square, right? So the square root of a 4 is a 2. So this is going to be 2 square roots of 6. Alright, you did this one for me. Okay, so square root of 63 is what? 9 times 7. So, square root of a 9 is a perfect square, so that's 3 times the square roots of 7. Alright, y'all do this one for me. Okay, so take your 72, divide it by perfect squares. So 72 divided by perfect square 4. So that's 72 is 4 times 18. But it's also 36 times 2. So which one of these would be the largest perfect square? That 36, right? So 72 can be rewritten as the square root of 36 times the square root of a 2. Square root of 36 is a 6, and you'll have left a square root of a 2 underneath there. Okay. Alright, so for word number 4. Number 4, I've got a 245. It ends in a 5 right here. So I'm going to divide this number, this big number, by 5 and just see what I get. So 245 divided by 5 is 49. So 245 is 5 times 49, right? Put it in your calculator. 5 times 49 gives you a 245. So this is going to be the square root of, and 49 happens to be a perfect square. If it didn't, I would keep going to see if I needed to do anything more. But since that ended in 5, I know that 5 goes into this number. So square root of 49 is a 7, and this is going to be 7 square roots of 5. Okay. So I'll do these. Square root of 90 and square root of 450. Okay, square root of 90 is 9 times 10. And that's about the largest perfect square that can go into this. So this is going to be the square root of 9 times square root of 10. This is just why it's so important to know your perfect squares. So I'm just going to say memorize those perfect squares. Know those perfect squares. So square root of 9 is a 30. And this is going to be 3 square roots of 10. Okay? All right. So 450. 450. So you could divide this number by a 2. I'm going to go a long way about this. Okay? 450 is 45 times 10. Right? Well, neither of these two numbers are perfect squares. Right? 45 is 5 times 8. Eight, 5 times 9. 10 is 5 times 2, right? So what multiplies to give you that 450 is 25 times 9 times 2, right? I just rewrote it because 5 times 5 gives you 25 right there. So what multiplies together to give you 450 is going to be the square root of 25 times the square root of a 9 times the square root of a 2. Square root of 25 is a 5. Square root of a 9 is a 3. And you're left with that square root of a 2. So 5 times 3 gives you 15 square roots of 2. Okay? What about perfect cubes? Okay? So that's 1 squared is a 1, 2 squared is an 8, 3 squared is a 27, 4 squared is a 60. I'm saying squared, right? So 1 cubed is a 1, a 2 cubed is an 8, a 3 cubed is a 27, a 4 cubed is a 64, a 5 cubed is a 125. Sorry, guys. A 6 cubed is a 216. 7 cubed is a 343. An 8 cubed is a 512. A 9 cubed is a 729. And a 10 cubed is 1,000. Basically adding 3 zeros. Okay, so perfect cubes we need to know. We're going to do this exactly like we're doing our squares. So we need to know these cubes. So the cube root of 1 is just going to be a 1. The cube root of 27 is going to be a 3. The cube root of a negative 64 is a negative 4. The cube root of 512 is an 8. The cube root of a negative 27 is going to be a negative 3. Okay, so we need to know, so if there's a negative under the radical, your answer is going to have a negative in it. There's a negative under a cube root, answer will be negative. Okay, so simplifying non-perfect cube roots. Okay, same thing as a non-perfect square. So you break it down, but when we do it, we need to find perfect cubes, right? All right, so let's look. If I took the cube root of a 40, so 40 I know is 8 times 5, or either of those perfect cubes. 8 is. So cube root of 40 is going to be the cube root of 8 times the cube root of a 5. Sorry, put the 5 in the wrong spot. Cube root of 5. So the cube root of 8 is just a 2, so this is going to be 2 cube roots of 5. Alright, what about the cube root of 500? I'm going to take this to the other page. Cube root of 500. Okay, cube root of 500. Cube root of 500 is 50 times 10, right? 50 is 5 times 10. 10 here is 5 times 2. 10 breaks down to 5 times 2, right? So if I was to rearrange this, how many 5s do I have right there? That's a 5 cubed there, right? So 5 times 5 times 5 is a 125. So it's a 125 times a 4. Okay. So the cube root of 500 is the cube root of 125 times the cube root of a 4. So the cube root of 125 is a 5, and then we'll stay with the cube root of a 4. Alright, y'all do this one for me. So, cube root of 432. So, 432 divided by 8 So 432 is 8 times 54. Okay. 54 is 6 times 9. So we're looking for a perfect cube in here. 8 is 4 times 2. So far I don't have any perfect cubes. Okay. 4 is 2 times 2, right? Or I lied. 8 is a perfect cube. So I could just stop right there. So this is going to be the cube root of 8. Why do I keep writing it right there? Cube root of 8 times the cube root of 54. But can 54 break down some more? So the cube root of 8 is a 2. And then we've got the cube root of 54. So I said that 54 is 6 times a 9. So 6 is what? 3 times 2. And then 9 is 3 times 3. So this is also going to be 3 times 3 times 3, which is a 27, times the cube root of 2. Cube root of 27 is a 3. So this is going to be a 6 cube root of 2. Okay, I'll do this one for me. "96 is an 8 times a 12. An 8 there is my only perfect cubed. So this is going to be the cube root of 8 times the cube root of 12. Cube root of 8 is a 2, and then 12. 12 is, 2 times 6? And 6 is 2 times 3. And you cannot rearrange those anyway to get 3 things that multiply together. So we are done with that one there. So it's just going to be 2 cube roots of 12. Okay? If y'all will, just start working on your homework. And if y'all have any questions about anything, let me know. Y'all have a great weekend.